Hi guys, thanks for joining me tonight. Nice to see you guys. We're going to go through a lesson today on some subatomic particles. We're going to look at a chart, and it's a pretty big chart with a lot going on, but we're just going to look at a small part of it today, and we'll take a lot of time tomorrow to analyze the different parts. So I've realized I can't do the video of myself while I'm also doing the lesson, so I'm going to start by videotaping myself just so you guys can see me here, and then I'll come back to myself at the end, but we're really just going to follow the PowerPoint lesson as we're going through the video. Alright, so let's get started. Our goal for today is to analyze the charges on a subatomic particle. And so the chart that we're going to see is this one, and as you can tell there's a lot going on in the chart. So tomorrow we're going to do a larger activity to understand the classification of matter chart on your left. We're just briefly going to look at it tonight, and our focus today or during the video is going to be the particles of the Standard Model, the different quarks and leptons and their charges. Specifically tonight we're going to look at the quarks. Alright, so I just want to start here. If we look at the hadron side of the matter chart and then the baryons and the mesons. It kind of sounds like circus names, but bear with us. If we look at the baryons have 3 quarks, and the mesons have a quark and an antiquark. Doesn't make a lot of sense at this point, but if you hang on, we do need to remember that. Baryons have 3 quarks, and mesons have a quark and an antiquark. Alright, let me go back. So if we look at our quarks in the particle of the Standard Model, they have a bunch of strange names, as you can see. Up, charm, top, down, strange, bottom, and they all have a corresponding charge. So for instance, the up charge has a positive 2/3 E. So that's 2/3 of the elementary charge, 2/3 times 1.6 times 10 to the negative 19th. And the whole top line has that charge, and then below that you've got your down strange and bottom quarks that have negative 1/3 times the elementary charge. So I want to start here by reviewing Millikan's oil drop experiment. What did Millikan conclude in the oil drop experiment? Wait for it. His main conclusion was that all objects have charges that are whole number multiples of the elementary charge. The elementary charge was 1.6 times 10 to the negative 19th coulombs. And every single oil drop had a multiple of that charge. There was never 1.5 times that charge. It was always 1, 2, 3. So we went 1.6, 3.2, 4.8, so on and so forth. Charge cannot be broken into fractions. Well, if we go back, we could see, hey, all of our quarks do have fractional charges, so how do we have to shift our understanding of Millikan's conclusions? And here's what we're going to say. The particles within a baryon can have fractional charges. So our most common baryons are protons and neutrons. Proton has a positive 1 times E charge, 1.6 times 10 to the negative 19th coulombs. A neutron has no charge. But within the proton, within the neutron, and within other baryons, we do have fractional charges. But when we put these charges together to form a baryon, and as we'll see a meson as well, they still only form whole number charges. Alright, so first we're going to look at baryons. Baryons have 3 quarks. They could have any of the 3 quarks. Certain particles are more common, such as the proton and neutron, but we could put these together in different orders. So let's look at a couple of examples. Let's first look at the charge on a baryon with a composition of CDU. So it has a charm particle, a down particle, and an up particle, a CDU. So we have to add every single individual charge. The charm particle is positive 2/3 E. A down particle is negative 1/3 E. If I put those two together, I've got 2/3 plus negative 1/3. I've still got a third, positive. When I add in a U, I had a positive 1/3 plus another 2/3 E. I have plus 1. If you didn't catch that, Rewind 20 seconds and see that again. All right, let's look at an SSB particle, a strange bottom particle. So we got negative 1/3 plus negative 1/3 plus negative 1/3, a negative 1 E charge, right? Negative 1.6 times 10 to the negative 19th, but here we're just concerned with the negative 1. What are the possible charges on a baryon that only contain charm and bottom quarks? So let's say we took 3 charm quarks and put them all together. So we had positive 2/3 plus positive 2/3, that's 4/3, plus another positive 2/3, that's a CCC. We end up with a positive 2 charge. Again, if you didn't follow that, go back, rewind, watch that again. A CCC is positive 2/3 plus positive 2/3 plus positive 2/3. We get positive 2. If we take one of those charm quarks away and replace it with a bottom quark, we now have positive 2/3 plus positive 2/3, 4/3 again, but now we're going to subtract 1/3 when we add that last bottom particle in. So we're down to positive 1. So the possible charges so far are positive 2 and positive 1. Let's now do 1 charm, 2 bottoms. So positive 2/3 minus 1/3 minus 1/3, we get 0. All right, now let's start adding in more bottom quarks. Let's do all 3 bottom quarks. Negative 1/3, negative 1/3, negative 1/3, negative 1/3, 3 of them. We get negative 1. And so the answer here is, I forgot to add it in, I'm sorry. We have a 0 there too. We get positive 2 or positive 1 or 0 or negative 1. It's not important that we remember all the different possible charges. The important recognition here is that we only have whole numbers. Even though the different particles have fractions, when we put them together to form a baryon, we only get whole number charges. Antiparticles. If we go back to the chart at the very bottom, we can see that for each particle, there is a corresponding antiparticle with a charge opposite that of its associated particle. For every particle, there's a corresponding antiparticle with a charge opposite that of its associated particle. So that's what the notes say. For every particle, there's an associated antiparticle with the same mass and opposite charge. For example, the antiparticle of the electron is the positively charged anti-electron, or positron. Instead of having a negative charge like the electron, it's the opposite. That's what an antiparticle is. They still have the same mass. So if we look at the chart and we look at the different particles, let's look just at the quarks. The top column of the quarks have positive 2/3 E charge. If we looked at the corresponding antiparticle, they would have negative 2/3 E. Same charge, just opposite in sign. If we look at the down strange bottom, again, all positive 1/3 when we're talking about their antiparticle. Why does that matter to us now? When we look at mesons, and if we go way back, the mesons have a quark and an antiquark. So let's look at different examples. Uh-oh, that wasn't supposed to come up like that, but you're going to get the answer right now. If we look at a U in an anti-U meson, an up particle and an anti-up, we have positive 2/3 and negative 2/3. That's 0. If we look at a U in an anti-C, right? So a U positive 2/3 and an anti-C, an anti-charm particle, that's a negative 2/3, we get 0. If we look at an up and an anti-down, we have positive 2/3 and negative 1/3 flipped, because so the anti-down particle has a positive 1/3, so the charge there is 1. If we look at a down and an anti-strange particle, we have negative 1/3, and then an anti-strange particle has positive 1/3. That gives me a charge of, uh-oh, I made a mistake there, didn't I? A D and an anti-S has a charge of 0. I apologize. It should say 0 there. So the important realization here, again, is that we only have whole number charges. You should, at this point, be able to calculate some basic charges and understand the results of Millikan's oil drop experiment. That's a review, and understand it's how this new chart has an impact on that. All right, that's tomorrow's lesson. All right, so I'm back. Tomorrow we're going to take a look at the hadron, the baryon, and the meson. We're going to read an article and fill in a chart that gives us a lot more information about that side of the chart, and we'll practice more on calculating charges. That's all for tonight. Make sure you finish answering the questions on the Google form. There are a couple of them. Make sure it's done by 8 a.m. tomorrow morning so I can get those answers graded, and an email will be sent out to you. Thanks, guys.